Morning everyone. Once again I welcome back to all of you to my channel Stream Mechanical. So today in this video I'm going to discuss a problem from phase diagram, and this is about me. My name is Mintu Pal. I am a research scholar in Department of Mechanical Engineering, IIT Madras. So let's go to the question. So this is the question. Please read the question carefully. For 1 kg alloy of SnPb, find out the amount of Sn and Pb in alpha and beta phases at eutectic point. So the few points that are important. First is eutectic point, the amount of total alloy, and we have to find out the amount of Sn and Pb. So these are the few points we have to observe from the question. And related to the question, this phase diagram is given. Okay. So in this phase diagram, first thing you have to observe that whatever the data or the percentage are given, these percentages actually the percentages of Sn or Pb. This thing first you have to identify. Suppose think that this is not given, like composition of weight percentage of Sn, this one is written here, but forget that this one is not written. Then how you will be identify? There is a very common thing here. Pb is written now, so the percentage of Pb at this corner is actually 100%. Okay, and similarly here Sn is written, so the percentage of Sn to this corner is 100%. Now there is a common thing. If Pb is 100% at this corner, then when I will be go to the right hand side, then the percentage of Pb should decrease. But here what you are observing, percentages are increasing, means whatever the data are given here, those data are actually not related to the Pb. These data are related to the percentage of Sn. So first thing you have to identify this thing, and you can see here it is written, okay, composition weight percentage of Sn. Now second thing, we have to find out that actually for where I have to find out that Sn and Pb, because here they are not directly said na. In most of the question they said that okay, we have an alloy like 20% of Sn and Pb, so find out this and that for this alloy. But here they didn't say that the percentage of Sn or Pb in the alloy. Instead of that they said that the eutectic point. So first we have to understand what do you mean by eutectic. So let me write down, not only eutectic, for eutectoid as well as for peritectic. So if they had said that eutectoid point, so eutectoid point or eutectoid reaction means we will be get two solid from one solid. Okay, this is the eutectoid reaction. Similarly, eutectic reaction means there we have one liquid, and from that one liquid we will be get two different solid. Similarly, if they are saying peritectic, then there will be one liquid and one solid, and from that we will be get second solid. Okay, now here they said that eutectic point, we have to solve the question at eutectic point. Now try to find out the eutectic point in this diagram. What is the condition for eutectic point? One liquid will be converted into two different solid during cooling, obviously during cooling. Okay, I'm talking about during cooling, not for heating. So we can see this point. In this point what happened? We have liquid to this side, we have alpha and beta to this side. Alpha is my solid 1, let's say, and beta is my solid 2. So what we can observe, that in this point here one liquid convert into two solid, correct or not? So our eutectic point is basically this point. Okay, this is the eutectic point. So we have to solve this question corresponding to this point. So this is the first point you have to observe. Okay, now let's, when we know the point, now write down what is the alloying percentage corresponding to this eutectic point. So at this eutectic point, the allowing percentage is 61.9 percentages of what in terms of SN. Already I told that these data are given corresponding to the SN. So 61.9 percentage of SN and remaining is PB. So this is our first point we have to observe and write down. What is the percentage of SN and PB or the allowing element at that particular point where we have to solve the question. Next, what they ask, find out the amount of SN and PB in which? In alpha and beta. So first we have to find out the alpha and beta. Okay, so let's find out the percentage of alpha and beta in this point. So percentage of alpha and percentage of beta. And how to find out the phase percentage in a diagram? To find out the phase percentage, we have to take the help of lever rule. Okay, so lever rule, actually we have to draw a horizontal line in phase diagram in such a way that these two ends, this end and this end, are meet two different phases, and there the phase should be pure phase. Means if this point meet alpha phase, then here alpha is pure alpha, no beta, here not beta. Similarly, if we talk about this point, if this point touch the beta phase, then here no alpha, no alpha. So in this diagram, this is basically the horizontal line. Okay, so here we have this side alpha, pure alpha, here this side pure beta. So let's write down the percentage of SN. 97.8 in this point, here we have 61.9, here we have 18.3. By the way, you can solve this question by taking the percentage of PB also, but in that case you have to subtract like 100 minus 18.3, again 100 minus 61.9, 100 minus 97.8. But actually this one is not required. Don't try to do this kind of thing. Whatever the data given in terms of SN, so take these on and solve the question, so you will get the same answer. So we have to find out. So now this is the actually horizontal line. We can take help of this and find out the percentage of alpha. So for percentage of alpha, and we know alpha is this direction now. So in the numerator we have to take the opposite segment. Opposite segment means this one. So difference is here 97.8 minus 61.9. We have to consider actually this difference. Okay, opposite segment difference. So 97.8 by 61.9, and below is the whole from here to here. So this is the whole distance, 97.8 minus 18.3. So when I will be solve this one, you will be get around 0.4516. Okay, this is the percentage of alpha. Similarly, percentage of beta, you can simply subtract from 1 when 1 minus 0.4516, or simply you can write like this also. So I want to find out the percentage of beta, means the opposite segment. Opposite segment in case of beta is this one, correct? So 61.9 minus 18.3 by total distance, that is 97.8 minus 18.3. So this one you will be get around 0.5484. Okay, this is the percentage of alpha and beta, but this is in terms of fraction. Okay, this is the fraction, but we need total amount. And what is the total amount of alloy? Total alloy, we have 1 kg, that is nothing but equal to the 1000 gram. Okay, you can solve it in terms of kg also, but you will be get a fraction value, so it is better to convert it into gram. Okay, so this is the 1000 gram. So alpha in 1000 gram, what is the total alpha? Alpha is equal to 1000, but in that 1000, this is the fraction of alpha. So 0.4516 means 451.6 gram. This is the amount of alpha. Then beta, same thing, you can subtract from 1000. Okay, because if this is the alpha, remaining is beta, because we have only alpha and beta na. So 1000 minus 451.6, or if you want you can do this thing also, like 1000 into 0.5484. so you will get around 548.4 gram. Okay, so these are the amount of alpha and beta. But what we want that in this 451.76 gram, how much SN is present and how much PB is present. Similarly, in this 548.4 gram, how much SN is present, how much PB is present. So let's say first consider the alpha phase. Okay, first consider the alpha phase, and we know the total alpha is 540. How much it was? 451.6. Sorry, it's not 451.6 gram. Now what is the composition of alpha? First write down the composition of alpha. From this diagram, what is the composition of alpha? To know the composition of alpha, just draw a horizontal line corresponding to that particular temperature or particular point. Here this is the particular point now, so corresponding to this particular point, draw a horizontal line towards that phase. I want to find out the composition of alpha, so towards that alpha phase, and when this line touch the point where after that we have a pure alpha, so corresponding to that line, consider that composition of alloy. So here corresponding to this point we have composition of SN, like SN percentage is 18.3 and remaining 81.7 percentage is PB. Okay, simply 100 minus this amount. So now SN in alpha is equal to, we have 18.3 by 100 into this total amount is 451.6, correct? So if you calculate this thing, you will be get around 82.6428 gram. This is the amount of SN in alpha. Similarly, PB in alpha, I have total alpha 451.6. In this total alpha, if I subtract the SN, the remaining will be my beta. Sorry, remaining will be my lead PB. So let's subtract this thing, 82.6428. Okay, or if you want, you can write like 81.7 by 100 into your total amount 451.6 as your wish. You will get same answer in both the cases, and it will be around 368.9572 gram. Please check these values. Okay, these amounts are okay, but this, please check this amount calculation. Okay, now this is for alpha phase. These are actually the answer. The SN in alpha this much gram, PB in alpha this much gram. Now for beta phase. For beta phase, total amount of beta was 548.4. 548.4, correct? 548.4 in terms of gram. What is the composition of, okay, let me change the color. What is the composition of beta? Beta composition is the same rules we have to follow. Where we have to find out the composition, just we want to find out the composition of beta corresponding to this point. Okay, so draw a line towards that particular phase. For beta phase, in this direction we have a beta phase, so just draw a particular line, and where this line will touch the pure beta, just corresponding to that line, draw one more vertical line and take the composition of alloy corresponding to that line. So here beta composition is SN, percentage of SN is 97.8 and percentage of Pb will be remaining, means 2.2%. okay, so now Sn in beta will be 97.8 by 100, and total amount we have 548.4, and if you calculate this thing you will be get around 536.3352 gram. okay, now this is the Sn. Now the remaining is the Pb in beta. The same thing, either you can subtract from 548.4 minus whatever the value you get, 536.3352, or if you want you can calculate like 2.2 by 100 into total amount is 548.4, and you will get around 12.0648 gram. okay, so these two actually my answer, this 4 value, like this one is one answer, that the amount of Sn in alpha and amount of Sn in beta. Similarly, the amount of Pb in alpha and amount of Pb in beta. okay, so what are the steps basically I followed? Let me go to the first page. So first step what I followed, first find out the percentage of alpha and beta. Then in second stage find out the amount of alpha and beta, because we have to find total amount, that in that total amount then find out the composition of alpha and composition of beta. Then in the fourth step you can find out the amount of Sn and Pb in beta, in alpha and in beta. So these are the steps you have to follow. okay, so I hope you get the idea that how to find out the percentage of alloying element or the amount of alloying element in a particular amount of alloy. Correct. So first we have to find out the amount of phases, then in that phases the amount of particular alloying element. okay, so in this video this much only. If you think the video is helpful, then please like this video and subscribe my channel. Thank you so much.